Can you type that we're on? Okay, great. Sorry about that little hiccup. So during last few sales meetings we've had, weekly meetings, it's been clear that there's been an uptick in interest from our customers with respect to new facilities for building as well, and adding solar to those facilities instead of our normal course of action, which is retrofitting to the roof or somewhere on the property. So we thought this would be a great time to put together a webinar on when we should be involved and how we could support the process of adding solar energy during the design process as you go forward with your new facilities. So my name is Matthew Norgard, and I'm a renewable energy consultant, and we're joined by Shannon Ware, who is our engineering manager. Good afternoon, Shannon. Thanks for joining.
Okay, good afternoon.
So we've put together a slide deck here for highlights and high points to think about when you're considering adding solar to your design process and your engineering process of putting your new facility together. So Shannon, could you just go over this slide really quick, because we thought this was great because it has ground mount and roof mount.
Yeah, this is a nice overview. I mean, this was put on an existing building, but it shows, for example, in this one we have a ground mount on the south side of the building, and there were actually some challenges there on the terrain. So that's some of the issues we would need to know about. And then this is a flat metal roof, standing seam type. And then we have inverters up on the roof in this particular case. So they're just kind of a nice overview.
Absolutely. So some of the considerations that we would like you to take into account during your design are listed here on the screen. Shannon, can you go into a little more?
Sure. Well, of course, when we're dealing with a building, a new building, obviously structural is a big issue, because when we're retrofitting it to an existing building, it's always sometimes a challenge to get information on what the roof was designed for, and the loads. So if we can get involved early up front in the design, we can work with you to give you some idea of how much load the solar array might add to your roof, and make sure that there's enough capacity designed into the roof. And one reason we bring this up is, especially sometimes on some pre-engineered type metal buildings, they're value engineered. So sometimes they have less excess dead load capacity than more traditional construction. So that sometimes can cause an issue if they don't have enough to handle the type of system we want to put up there.
So you're saying, if we're involved from the very beginning, even to a pre-engineered building, we could help with the new loading requirements, and then that's a great time to do the re-engineering during that initial process versus waiting for another revision.
Yeah, we can make sure that we aren't going to run into any issues later. But typically we would need to have some idea, because we have structural engineers we work with also. We would need some info on the design of the roof and the support structure and what it was designed for. And then we also have to take into consideration what's the wind load in the area, for example. And then the height of the building is important, because if it's a really tall building, you have more, especially more wind load requirements, because the winds tends to be stronger at on higher buildings. We need to know the roof pitch, if it's flat, or what the pitch is. Low slope is usually up to about 3 or 4 degrees, and then anything more than that, it affects the type of racking and support structure we use. We do need to know the building dimensions, because some larger buildings may require different offsets from the roof edge for wind load. Parapet height can affect the wind calculations as well. If it's taller, it might be potential shade that we have to allow for. And then we just need to know what the site conditions are. Is it in town with a lot of buildings around it, or is out in a remote area with open fields and open country, again, that affects the wind exposure.
Okay, that's good information. Now, looking at this picture we have, we can see obviously we've retrofitted this. But if we were to meet with this owner who was designing this building and it hadn't been built yet, we'd say, what? Can we move that mechanical equipment that's in the middle of the two arrays? Can we move that to one side? Is that something we would add? Like,
well, I don't know what, we're going to address that a little later. But yeah, in this case, actually, this roof isn't bad because the equipment's all kind of clustered in two areas. So although ideally in this particular picture, if that equipment could have been located, say, over to the west edge of the building, it would allow us to put in a cleaner solar array, for example. So you can't always move that stuff around, but that's some things to think about. Yeah,
to think about and discuss and kick around with the architect and the engineers and the structural team. Here's another example of, and that leads us into the mechanical portion of it.
Right. So yeah, this picture is another metal roof building with a medium pitch. So you can see that's a different kind of a racking. That's going to be an attached racking system. But yeah, the key thing is your HVAC mechanical. And if we're early enough in the design process, if there's any option to make sure that you're, especially like a HVAC condenser and units and stuff, if they can be lined up in a straight line rather than scattered around, sometimes you're constrained by how the building is designed. But anything we can do like that, the most ideal is to put your stuff at the north edge of a roof if you can. That way we're south of it, because we always want to be trying to get good southern exposure for the solar array for production. Another thing that we need to know is mostly on flat roofs is where the roof drains are located. There are some drains we can bridge over with our racking, and there's others that have large cages that kind of stick up, and those are a little more difficult. In any case, we need to allow for those when we're doing our planning. And then we do need to know very much the roof type and roof surface, especially on a flat roof. I think we've got a slide later of the different types, but depending on what the roof covering is, whether it's EPDM, membrane, or some other type of roof, that also affects how we do our design work. And then there's many different types of racking support systems for the solar modules, and so the particular characteristics of the roof will determine which type we use and pick. And then we also have to allow for fire access and service access for equipment on the roof. That's governed mostly by building codes. But those are all some of the things we have to take into account.
Yeah, and the earlier we're involved in these conversations, the better, because at the end of the day, we're going to ask for things that would make the installation for the solar smoother, but it may not work in the overall plan for the entire building, which we realize, but we certainly just want to be part of that conversation. Is that what you're saying?
Correct. Yes. Earlier is always better.
Exactly.
Because I have seen roofs where there's a lot of smaller condenser units that are scattered about because the architect or wherever, they just kind of left it to the mechanical subcontractor to put stuff wherever they wanted to. And sometimes there's a lot of opportunities to adjust that stuff around a bit and optimize the locations a little better for the solar.
Agreed. Perfect. Yeah. Earlier, the better. I think we're going to say that quite a bit today. Let's talk about roof surface optimization and how that drives our design and our strategy.
Well, this isn't really optimization here, I guess. This is kind of a follow-on. This is just showing some of your different types of mostly flat roofs is where we run into these. A lot of your older roofs are your built-up roof types, which are usually hot asphalt. You don't see this much in new construction as much, but a lot of older designs use the built up, sometimes had gravel embedded in the top. And there were sometimes some membrane roofs that had gravel ballast on top. Those are kind of special cases. Modified bitumen is your torch down roof. I think that is still used some. It's not quite as common. Most new construction on flat roofs is using a TPO or EPDM, which are membrane type roofs. And they're put on large rolls and they're sealed with a air gun, heat sealed for the seams. And the main thing we need to know about those is we need to know the manufacturer, because sometimes we have to talk to the manufacturer directly to make sure we maintain the roof warranty for the covering. We also want to know whether the membrane roof is mechanically fastened or what they call fully adhered. Fully adhered, they actually put adhesive down on the deck underneath, and the membrane is actually literally glued down. A mechanically fastened one, sometimes I think it's a little less expensive to do, but that means the membrane is actually loose, and as in the gentleman in the top left picture there is doing, it's actually fastened down with fasteners. We do need to know that because we may have to supplement if we're using a ballasted solar array, which we have some pictures of, we may have to supplement that with some mechanical attachments as well, because the mechanically attached membrane can sometimes move around in wind. So we just need to know all of those things so we can consult with the racking companies and our engineers to come up with the best system for that particular installation.
And we don't have a choice a lot of times in the type of roof, but we can certainly have solutions that work with all of these and more, correct?
Right. It's mainly making sure we get all the information so that we can give an accurate design and do all the planning and estimating and everything. So there's trying to minimize surprises for everyone.
Exactly. Yeah, I don't like those either. Now let's talk about new construction, but every now and then we'll come across a new construction that says we've got this land that either is unusable to us and we'd like to find a use for it, which is a lot of time is ground mount, or they just say we don't want anything on a roof because of future expansion, but we've got this area for ground mount, and that's something we want to be involved in early as well. Correct?
Ground mount, the main issues we might come up with a new construction is if say, oh well, let's put this. We'd like you to design an array for this section of land here, and then we find out that maybe you're planning to build a new building nearby. Well, we need to make sure that we're not putting this array such that, say, the new building is going to end up causing shade on the array. For example, things like that. Then we also need to take into consideration where we're going to interconnect the electrical output from the solar array if it's a ground mount. That's what POCC stands for, point of common connection. That's what the utility companies call it, where we tap in and run in parallel to your utility feed. So if that's a long distance, that obviously increases costs, and then we also have to determine where the path for that feed is going to be. It's typically an underground line. Often we do directional boring for those, so we can actually go under some things. But again, that's all something we need to take into account. And then, just making sure we have sufficient area, and we usually need a little space around it. In some jurisdictions, we may be required to put a fence up around this, and there has to be enough. Usually want about 10 feet around the array plus the fence. So these are all things that have to be accounted for.
Okay, great. That's a good picture and great advice on things to think about for ground mounts. You mentioned this a little bit, but can you go a little deeper dive into the electrical interconnection?
Sure. Again, here, this picture here is actually a standing seam metal roof with we call a flush array that's parallel to the roof surface. So obviously we have DC wires coming off of the solar modules themselves, but then those have to go into the inverter that produces the AC power. So one thing we have to consider is where we put those inverters. Sometimes there's opportunities to put them on the roof. That first slide at the top showed that. That may or may not always be the best location. But then we have to, if we're going to plant, and typically the inverters, if it's, can often be located close to where the main service is coming in. So we have to plan for routes for conduit or cable tray to run the conductors off the roof down to where the inverters are. So those are some of the things we need to allow for. That's why we need to know where the transformer is, where the service is, electric room, all those sorts of things. And again, if it's new construction, there might be opportunities, for example, to have a chase coming down from the roof where we could run electrical wires directly in. That's a clean way to do it. It doesn't happen too often, but then we don't have to have stuff like cascading over the side of the building or something, for example, or we can avoid having to add roof penetrations later.
Yeah, that's important. It's always a question we get is roof penetrations, but I didn't really think about the running the lines through a chase that maybe we could take advantage of during the design process and get that in.
It all depends on the building type, how we do that. And there's very safe and reliable ways to do roof penetrations in every type of roof, so that can be done. But and then the other thing is if you're planning to have a generator, we need to know that, so because that affects how we integrate or tap into the system, because in most cases we have to be upstream or more toward the utility side of the generator transfer switch. So there's some of the details we need to think about, because the solar array, the standard solar array, can't directly backfeed into an emergency generator. There are ways to do that, but it's a much more complicated system.
So we need to be involved at the time of an electrical one line and get on that as soon as possible in terms of that.
And that's a good point, because if we can, sometimes there's an opportunity if the main MDP or the main distribution panel has enough capacity. Say, hey, if you could plan to have an empty space in this panel so that we could put a breaker in there, we might be able to land directly on the panel instead of outside, for example. So
yeah, go ahead. Sorry.
I was just that's it. Just going to say, if we can get involved in the electrical plan or get the electrical one line for the facility early in the process, that helps us out also.
Yeah, it helps us, but we don't look at it from just a solar energy project's point of view. We're trying to be as integrated into your overall electrical design, which will hopefully save money for the entire project, not just the solar array, but just, for the entire construction of the facility. If there's something we can get involved in early on that saves money, we want to have that opportunity. The next slide is financing considerations. A lot of times the owners, when we talk to owners, there's two main choices, and the majority of the time it's a cash purchase, and that is where the owner would pay for it and then reap the benefits of the energy savings, the federal tax credits, the depreciation, and that would be the reasons for doing it, along with the renewable energy and the green concepts. But a lot of times on new construction, the depreciation, which is a large part of the return on investment for a cash purchase, that depreciation amount is not needed when you're building a new facility, because obviously you're going to have a lot of depreciation associated with that already. So an RC lease might be a great way to get solar energy involved or installed on your facility with very little money, if zero money down. You wouldn't reap all the tax benefits or the depreciation benefits, but you would get the same array installed on your facility without money down. So there's a couple different ways and financial tools that we like to assist owners with. We just want to point those out. Obviously, we can drill down deeper on an individual basis. So reach out to your energy consultant on that, your Simpleray energy consultant, and we can certainly do the pros and cons of each of these options with you. But just wanted to point that out. It's not involved directly in the design of the facility, but it's certainly involved in your decision-making process with respect to solar in your new facility. But so in summary, we're here to help. We live and breathe solar. We are passionate about it, and we want it to be part of your new builds, not just your retrofits. But we know we need to come in at the very beginning and do some upfront work with yourself as an owner, and with your architect, with your construction folks, to try to minimize any issues that may come along if we're involved early. This is a great way to save money. It's a great way to maximize your ROI. And also it's a great way to make sure, as a couple examples we were talking about, we can make it look more aesthetically pleasing if we're involved early with the project, and give you an overall successful project based on finances, based on green energy, and based on an overall facility point of view. Shannon, any final comments?
No, I don't know if we have any questions. We do have a few pictures of some typical systems. If you want to run through those just to show people what they look like. But ask questions if you have any. Yeah, this is a fairly large ground mount rack system. Just shows how we do it. And in this particular case, we're kind of pioneered using some new types of raceway, so we can pretty much hide all the wires. This also lets us take advantage. These particular panels are what's called bifacial, which means they can generate some power from the backside also. So by having fewer wires, there's less shading. We can get a little additional production out of them. Again, this is just another overhead view of a typical metal building, and so there's opportunities. In this case, I think this is what's called the building's actually running north and south. So we've got arrays on both sides of the roof so that they'll produce both in the morning and the afternoon.
Okay. Here's your racking.
Here's a typical, what we call ballasted racking. This is a TPO roof. And in this case, we do have an inverter up on the roof. And this is a fully ballasted system. The concrete blocks and the little trays are what support it or keep it from moving. We're also using cable trays plus conduit to route the wiring.
More of the same?
Here's more shots of the same type. This is Unirack RM10 racking, ballasted racking. There's different types of this type of racking too. And we may look at other slightly different versions depending on the roof type and roof situation. In this case, you can see on the left picture, there's one of those roof drains with a very tall cage over the top. So we have to make sure that that doesn't interfere with our array.
Good point. And then there's just a close-up of that.
More close-up showing that, yeah. And I would point out that a number of these photos were taken during installation. So you're seeing wires that are kind of loose. When we're done, the wires are all dressed and up underneath the modules. So nothing's laying on the roof surface. So
yeah, good point. Wire management is critical to us and to the success of the project. So this is a ongoing project that we have photos of. But I think that's the last photo.
Okay.
I don't see any questions. So if you don't have any more comments, Shannon, I think we can wrap this up.
No. Questions, anyone?
Okay, I think we're done here. Appreciate everybody for participating and signing in and logging in. Once again, we always appreciate your interest in solar, and we look forward to helping you with your new facilities or existing facilities, trying to find a solution that works best for you. We look forward to meeting with all you folks who joined us. Thank you.
And if you think of questions later, just feel free to send them to us, and we'll see if we can answer them.
Absolutely. Thank you, Shannon.
Okay, thanks.